Welcome to the Infill Podcast, where we interview the most interesting members of the 3D printing and maker communities, live and with audience participation. And now, here is your host, Jonathan Levy.
Greetings, everyone, and welcome. I'm really excited to have you guys all. We get started, and I tell you guys about our incredible. Let me go ahead and thank this episode's first sponsor, which is Octo Everywhere. So as you guys know, Octo Everywhere allows you to print from anywhere you happen to be in the world, monitor your printers using AI, and much, much more. You can actually see here, this is a printer that is at my parents' home in California, and I'm just about to print something for my mom, and I can just remote in securely to the printer, turn on the lighting, get the printer preheated so that as soon as we are done with this podcast, I can go ahead and print that thing for her. It's not just for that. As I said, AI can monitor your prints remotely and tell you if something's going a little wonky. You can use it to start prints, stop prints, and much, much more. So thank you to Octo Everywhere for supporting this channel. On to today's episode. You guys, today you are going to meet a friend of mine who I've collaborated with on past videos. His name is Justin, and he's been in 3D design for about 15 years. He's most well known on YouTube for his designs of speakers and 3D printing speakers and audio equipment. Justin, welcome to the show, my friend. How are you?
Pretty good. How are you, Jonathan?
Yeah, not too bad. I think maybe my audio levels are higher than yours. Let us know in the comments, guys, if it might also be that I have noise canceling on and I just don't hear myself. But let us know in the comments, guys, if our audio levels are not so good. Justin, I always do a very deliberately bad job on the intros because I'd love to hear a little bit in your words who you are, where you came from, how you got into 3D printing. Talk to us.
Okay, ready. So I'm Justin, as Jonathan said, and I kind of grew up here in the United States in a small town in Wyoming, which kind of cowboy Indians type thing is what comes to most people's mind. So not super technological in the world, but I got into the 3D printing space mainly for my passion in cars. So I really wanted to build some like fancy 3D printed speaker boxes for cars, and my woodworkings were not as great as my computer skills. Onto some just free CAD software and just started creating stuff. And I mean, I was lucky enough that I had access to an Ultimaker printer as my first printer. So my introduction to 3D printing was very seamless, and I did not experience a lot of the hurdles that some people did. So I think it was a very good introduction to the hobby, and I didn't have to overcome a lot of tinkering and just messing with it that a lot of people did. I could just design and print and design and print. So
okay, where was this Ultimaker that you had access to? I guess we should ask, what was your day job? What is your day job?
So my grandparents own a trucking company, and I'm just like the shop manager. But at that time, I was in college still, working for them in the summers and all that. And I just happened to save up enough money that I was like, this is what I want to build cars with. I want to be able to design my parts and put my parts on my cars, and got money for it and just made the big purchase.
Wow, really, really cool. So, what? Interesting enough, my equipment is failing me here again, but that's fine. What year was that? I mean, Ultimaker, that to me that sounds like it was a long time ago.
Well, it was Ultimaker 2, so 2014 maybe, 2015, something like that.
Okay, all right.
I would have been at the tail end of college, so.
And so you get into this and you start 3D printing speakers right away for cars. What were the challenges back then? As you said, an Ultimaker's a pretty capable machine, but I'm interested to hear the journey of like what's become more possible in those years of kind of rapid development of 3D printing.
I mean, my first few things were just like bezels and bezel plates and just like cup holder bezels and stuff for like custom speaker boxes for like center consoles and stuff, like big subwoofers in the center of a vehicle type thing. And then I kind of got into the more of the CAD design around the house as I bought a house and found out owning a house is very, very expensive.
Oh, yes.
And so um, it was more just I can save money by 3D printing myself some coasters and 3D printing myself little holders for things in the house and this and that. And I got good enough at CAD that I was just one day I was like, I want to print an actual speaker. But the limitation there was that Ultimaker, it was a Bowden system. And so TPU was kind of a no go for that type stuff.
Right.
And so I actually made the leap to downgrade, I guess, essentially into an Ender 3 that I could mod into a direct drive to start playing with some of those more exotic-y type filaments.
Huh. That's interesting. I don't think I realized that the Ultimakers back then were Bowden setups. I also didn't realize, I mean, it makes sense, TPU, but when you and I printed a speaker together, we didn't use any flexible materials. So I guess let me take a step back and ask, did you know anything about designing speakers back then, or was this all self-taught?
I mean, I kind of just got on YouTube and was like, how do you do this? I mean, I just as a kid, that was what I was taught to do. My parents weren't into that stuff. I didn't have friends into that stuff. So my next closest resource was the internet and I mean, YouTube essentially. So
It blew my mind when we worked together on the speakers that you helped me with because like I mean this might sound stupid to someone who is an audio engineer, but it is a science, right? It's part art, I'm sure, but it's also very much a science. And you're like, oh, we need an extra gram of material in here, or you know, we need to occupy this much space with batting because that's gonna create this frequency. It's amazing to me that you can learn so much of that on YouTube, right? It's kind of mind blowing.
mhm, it
What
really
were the
is. Yeah.
challenges back then? Like, besides TPU, I guess you were printing a lot of ABS probably on an Ultimaker, so that heat wasn't an issue.
No, I mean, ABS was kind of just, I didn't have issues with things like ABS like some of the other people had back in
Right.
like the early or mid 2010s.
Right.
And so I guess I would break this up into two segments where I was originally focused on designing speaker boxes and
Mm-hmm.
just like bezels and speaker boxes, where I would buy actual driver and put it in a box. And I did the calculations on the box. And the box was usually wood because it was for a subwoofer. And so it was, I mean, you're talking like 3 liter, 4 liter, 5 liter boxes.
Yeah.
So big boxes. And then I would break it into section 2 where I actually started to design and print the drivers themselves. So
Mm.
like when me and you collaborated, we built the enclosure, but we used a off the shelf type of driver.
Right.
And I thought that I could maybe with TPU and stuff, I thought I could print the flexible things like the surround and the spiders inside of the speakers that actually make it move up and down. And then you build the coils and the magnet for the motor. And I mean, I kind of just was playing around and experimenting with that.
Now I'm
So,
curious, what was it about speakers specifically? I mean, clearly you're an audiophile and a gearhead, but what is it about speakers specifically that lends itself to 3D printing? Because when we think of, you know, the applications of 3D printing, speakers isn't one that comes up directly, right? And I think a lot of people, myself included, have this misconception that like wood is very good for speakers because of certain properties of wood. But I imagine that in your experiences, you've learned like, oh no, I can do things that are just not possible with other mediums. So what does 3D printing bring to the mix when it comes to designing and making speakers?
so in the terms of actual speaker box construction, it brings the ability to kind of construct and design internal geometry in 3 dimensions. So you can break up a lot of the internal standing waves and a lot of the reflections that you would deal with otherwise. And you can actually build braces in where you need braces, put material where you need material, leave material out. And I've never actually done testing, but a lot of people have done testing on like wood versus PLA versus ABS. And PLA and wood actually come very close in terms of how the speaker will sound and perform at
Hmm.
an acoustic level.
That's interesting. I mean, I guess it kind of makes sense because PLA, maybe it does, maybe it doesn't, but PLA is, you know, a naturally sourced material, but at the same time, it doesn't have all that cellulose and other stuff that wood has in it.
Mhm.
I did actually see it form next. Asahi Kahei is a Japanese company, and they've now made PLA with cellulose fiber, and it has all
Oh.
these crazy properties. It kind of behaves like glass fiber, but it has weird and different properties that glass can't do, that only kind of like biofibers can do. That would be interesting for a speaker,
Mm.
potentially. What are some of the other things? So, okay, more complex geometries, ability to move material wherever we want. I imagine design wise, you can do much crazier stuff.
And I mean, overall, I guess the on-hand ability to build something is not as required because if you can make it in 3D on CAD and you can hit a
Right.
print button, it's a lot easier to bring into the real world and play with. And that was kind of my limitation was my craftsman ability in wood was severely lacking, and so 3D printers seemed like a way I could play with this type stuff and not have to have a fully functioning workshop for wood either.
That makes a lot of sense. Now, would you say that you are actually able, or in theory, one is actually able to make a better sounding, better performing speaker with 3D printing than even the most sophisticated, craftsman, or is it about equal?
I would say, given the appropriate, if each of them had the same knowledge, the 3D printer is going to be more capable of creating what you're wanting to happen.
Wow. That's really interesting. Now, I wonder if you've experimented with mixed materials. I mean, you and I did do a little bit of CNC wood, but it was mostly aesthetic. And I just wonder,
Mhm.
like, concrete. I know you use batting, acrylic batting, but like messing around
Mhm.
with concrete, messing around with adding wood, TPUs. Like,
Yeah.
share with us some of the interesting stuff that you've done on your channel or just in general.
Yeah. Yeah. So I've actually done, they're from my home theater system. They were a pair of 8-inch woofers for the low end of the frequency spectrum. And I printed the box in 4 sections, and then each one of those sections was done with like 3 perimeters and then like a really low, I think it was like 2% gyroid infill.
Oh,
And then I used a self-leveling concrete mix that I poured in, and I used that gyroid infill kind of as a plastic rebar
yep,
to reinforce the concrete
yep.
on that to give it this like really heavy, dense damping effect that you couldn't get from plastic. But I got to create the shape and all of the internal geometry in this plastic shape that I wanted. So it had a lot of nice radiuses, and it was just the shape to fit what I wanted. And so,
That's really cool. And I've done that as well using the plastic for rebar. Though folks told me in the comments that you have to be careful because I never realized concrete, when it cures, can actually get hotter than it can get up to like 60
hmm
C. So they're like, yeah, next
hmm
time if you do that, do it out of PETG or ABS, not PLA, because it can literally just.
yep.
Um,
Yeah, I don't have the hate for PETG like you, so a lot of my stuff is PETG.
oh man. At this point, it's just become like a meme, but I really do hate the stuff.
hmm
I'm excited to get Polymaker's new formula, which they're apparently sending over, because apparently it's better on a lot of the things that I don't like.
hmm
I I wonder, what else do you print a lot of, or are you really just focused on acoustics and speakers?
Um, I mean, I did do a whole bunch of stuff for a couple of my project cars,
Mm-hmm.
but I'm gonna say probably 70% of my stuff has been acoustics as of late.
Are
So
you still challenged by it? Because I feel like whenever I go down a rabbit hole of one specific type of thing that I'm printing, I burn myself out pretty quickly. And it sounds like you're still pretty
yeah,
excited about designing speakers. So what keeps you
yeah.
excited? Like, what are the challenges?
Um, I mean, I've started adding in other manufacturing processes into it. I've added vacuum forming, and I've actually 3D printed pieces and vacuum formed those pieces into more intricate shapes using 3D printed molds. So I 3D
Interesting.
printed a flat thing out of whatever material you want, and then I print another thing out of a higher temperature resistant material, and then thermoform it to that shape. And that
Wow.
was what I was using to create cones and stuff. And
Whoa.
then I most recently have ventured off into molds, and I was trying to cast aluminum and using 3D printed molds, and I was kind of successful on some stuff. I did a bracket for my pickup. I
Okay.
was unsuccessful on a speaker basket, but I kind of know where I need to head for that next. And then I also was playing with molds, and I currently have on my desk here two concrete speaker boxes that were made with 3D printed molds that they're 100% concrete. And I did it more for aesthetic purposes than anything, but it was really fun to kind of learn about how to demold with plastic to use the 3D printer in a less of a way of the end product, but more of a way to get
Right.
to the end product.
Right. I just saw I was at like this artist village up north, and they were telling me this artist was working with like super thin ceramic spin molding, and that she spent like half a year trying to get molds made out of wood and aluminum and tin and all this crazy stuff, and then eventually she just caved and had someone 3D printed for her, and it was like done in an afternoon, and the molds are so much more intricate than anyone could ever do in wood. um,
Mm-hmm.
it sounds to me like speakers are just your particular chosen avenue for experimenting with different mediums, and it's kind of like me in film gear, right? And like tripods and stuff like that.
Mm-hmm.
Like I'm messing around with concrete to try and make stabilization for my light stands, and it sounds like to me it's more just like your comfort zone of where to expand out in playing with different mediums and applications of 3D printing.
Yeah, I would say that it's just the base knowledge that I have is kind of
Right.
enough that I can really venture out and kind of push the limits of stuff without having to relearn the basics on another subject. And
That makes
so
a lot of
I
sense.
just I have this just core idea of how things should function and how they should work and what I can then change on that core function to kind of see how it affects that core function.
That makes a lot of sense, and it reminds me a lot of Cam from Blacktail Studio, where he's like, it seems like so mundane, but he mostly makes tables, and he makes tables out of like, hey, I'm gonna do this project out of uh, what was it like fossilized ivory, or I'm gonna make a table out of blue jeans, or I'm gonna make a table out of aluminum foil. Right? It's like he's really good with
Mhm,
epoxy. What can he put in the
mhm.
epoxy? I think that's really. I think there's a lesson there, like an actual life lesson or maker lesson, which is like pick your craft and create a fixed variable. I don't think that's the right term, but like a known quantity, right? Where it's like I'm really good at making cabinets, or I'm really good at making speakers, and then keep those parameters fixed while you experiment with the medium, the technology, the tools. You see a lot of woodworkers who make the same kind of table with the same kind of wood, but they're like, today I'm going to try and do it with a dado, and tomorrow I'm going to try and do it with a hand planer. And I think that's a valuable takeaway of like, okay, why should I go and try and tackle learning this whole new subject of, I don't know, designing desks when I know how to make a good speaker, but I don't know if I can make it out of concrete. I'm curious, like what techniques or materials are you most excited about to explore next year? Right? What are some things on your list that you're like, oh, that would be really cool if I could make it work?
Um, what I really want to play with is I've seen them at some of these shows, and I don't know when they'll be consumer ready, but I've seen the like silicone printing where they do it in the gel.
Yeah, dude.
And so things like that where you can print super flexible things, because that's kind of my limiting factor on building the actual driver is, I mean, you're getting around like 80 A on TPU, and most consumer grade things are going to start struggling to go softer than that. There's one
Yes.
extruder I think that'll go down to 60A, but I'm not sure which one it was.
Yeah,
I
I've
don't deal enough
struggled.
in that.
I have some 70A TPU, which I have struggled to print on every printer. I had some luck with the neck extruder, but I went up to a zero point 0.8 millimeter high flow nozzle. So just eliminating back pressure completely.
Hmm.
And the neck extruder is very good on flexibles, but yeah, as we speak, actually, in the other room, I've got some really funky materials trying to print on another printer. It's an
Yeah.
uphill
And then
battle. Yeah.
yeah, and then I seen that Proper Printing, he had a really cool like belt driven
Yes.
extruder, and I don't know how that would work for really, really soft materials, or if you're going to experience the same kind of pressure jams before it gets to the hot end.
I can put you in touch if you want. I think he's published it or he's about to publish it, and he made an XL with 5 of them at Formnext. Though I don't know if you saw it, you don't even need the gel printing. Did you see Prusa now has the silicone printing head for the XL?
I
I don't
did
know if you saw this.
not.
Oh, so they're
Mm-mm.
working with a local company here, actually, and what they do is it's two-part silicone, and then it's like a sausage casing basically. It's encased in a special casing, and then it slices the casing and injects the material, mixes it in the nozzle, and you can just on the Prusa XL print silicone, two-part silicone. It's
Oh,
crazy, and the quality is
that's pretty
like
cool.
really good. It's $1,000 just for the tool head and system, but I
Oh.
mean, compare that to like any other silicone printer.
Mm-hmm.
It's pretty bonkers. Um,
Yep.
and everyone's joking, like Thomas Sandlatter did all this like alluding, kind of like you could print, and he's showing things that look like sex toys, and he's like,
Mm-hmm.
you could print skin safe stuff, but speakers is a perfect example, right?
Mm-hmm.
That's
Yeah.
interesting.
And a while ago, I found this stuff, and I don't really know what it exactly was, but it was a there was like bubbles of PVA inside of a flexible material, and so you would print this, and it would come out like PLA hard, and then you would
Right.
take it and you would put it in a bath for 15, 18 hours, or if you had an ultrasonic cleaner, it was significantly shorter. And when it was out, it was soft like a 40A, 50A. The only
Whoa.
issue was whenever it dried out, it would kind of re-harden back up. So I could never get all the PVA to kind of release from the material. But it was probably some of the softest stuff that I'd got out of a printer, even if it had some post processing on it.
Have you tried these like foaming TPUs that are coming out now?
I've done a lot of that foaming TPU on most of the recent speakers, and I do believe it probably gets down to around like a 55-ish A, maybe a 60 A.
Okay.
But
And that's not enough, or you would want to go lower?
um, so I'm just kind of fighting on the Q factors of a lot of my speakers. I'm fighting the mechanical resonances on a lot of stuff, and it was a lot of those numbers that we were throwing around when we were building stuff, and I just want the mechanical one to go down because I'm honestly kind of scared of big magnets, and so I can't make the electronic or electric resonances kind of go down by using a stronger motor because I'm just kind of scared of bigger magnets at this point with some of the ones I've been using. I mean, 200 and some pound pole magnets are terrifying beyond anything
Yeah.
I've ever played with. So
Yeah, I
my
saw a
next
video
goal is to
with
kind of just,
Colin Furs recently. It's like I would not
yeah,
be putting two magnets that close to my
mm,
testicles.
yeah,
Just doesn't bode well if one of your welds fail.
no, yeah.
Uh,
So
wow. Yeah, they're terrifying.
yeah,
But that makes sense. 200 pounds is a serious magnet. That would take your fingers off, you know.
yeah, and I mean, you're assembling a motor around this, so you have a bottom plate, and then you put a ring magnet on it, and then you have to put metal pieces in the center of that, and then a top plate on that, and then a top plate on the ring magnet, and you have to align all that and center all that perfectly concentric for the speaker to work properly. And so you have to hold a ton of force very still while assembling it. And I mean, I don't know how the manufacturers do it. I don't know if they magnetize after assembly or how they do that, but
Huh, that is an interesting
because
thing.
they play with way bigger magnets than I will play with. I mean, I wear big leather welding gloves when I play with that stuff, and I mean, it'll pinch them and cut them, and Yeah.
Yeah, fair enough. They probably do it with robots or, like you said, magnetize after. Makes a lot of sense.
Hmm.
Where's a good place for people to start? Are there specific designs, I think it can be really overwhelming when if someone's like, hey, that's a cool potential project. Where can people get started? Are there like kits that you recommend for 3D printing out your first speakers?
Um, so I got a buddy over in Britain, and he actually does like a STEM-based kit that he's working on currently. Polymate 3D, I think, is his Paul from Polymate 3D,
Okay.
and it's kind of geared towards children, but I mean, even adults can learn from a lot of those STEM things for kids. And I mean, it's kind of just the basics of a speaker, and he's currently working on getting it down to, I think, two printable pieces and then a magnet, and you just wind coil around this and you have a
That's pretty
speaker. And
cool.
it's like no TPU, no nothing. He's used just like basically a spring out of PLA, like a long thin piece of
Hmm.
PLA printed to give it flexibility that way.
Huh.
So it's like a kind of a flat spring esque way,
That's cool.
but
That's cool.
it's
And then
the
what's the
I would say
step
it's
up from
this.
there?
um I mean, at that point, I mean, there are a few of them on some of the repositories where you can just print the stuff out and kind of assemble them. All of my stuff is usually on the repositories
Okay.
if I feel it's safe enough for somebody to assemble. If I'm playing with the 200-pound magnets, I just don't release those files because I'm like,
Okay. So you actually put all your models online. That's really cool. And people can
I
just
do. Yep.
print by the parts
Yeah.
that you used. The frequencies will be the
Yep.
same.
Yeah.
No
Yep.
kidding. Is there a
Hmm.
specific model that you would recommend like is good for someone who's listening and is like, I really want to try this out?
Um, the easiest one to assemble, it's probably going to be either the version 19 or the version 20, because before that I was using machined parts that I was getting from my sponsor.
Okay.
And so there's a kind of out of a normal person's reach unless they're wanting to spend a couple $100 probably.
Okay. That's
Um,
actually a really good segue and setup, though, to this episode's other sponsor. So I'm going to take that opportunity, which is none other than PCB Way, guys. So if you do need to get things machined and you do want that premium look and feel, PCB Way can help you out. They do CNC machining, but they also do 3D printing. They do PCB prototypes, many other technologies. I've used them for all kinds of CNC machining. All you need to do is take your files, drop your files in, select what you want them machined out of. It's super easy. You can even get them machined out of carbon fiber and select your options. And the parts just show up on your doorstep in perfect quality. They also have a real life engineer go over every single order before they manufacture it, just to make sure that there's nothing wrong with your design that would cause manufacturing errors. I highly recommend them, and you get $5 off your first order. So check them out. And thanks to PCB Way. Tell us about these machined parts. Like what in a speaker would be machined?
so it was a lot of the stuff that the magnet was going onto. So like the
Gotcha.
bottom plate and then the pole and the top. And I was doing it out of laser cut pieces of metal. And so I was having to basically assemble all of this and then kind of print jigs to center it all.
Got
And
it.
if I had machined, it was just a one piece, put it up, put the magnet on, and then put a
Got
top
it.
plate on. And it made assembly easier, and it probably a lot safer, to be honest, as well. So,
Right. So why stop doing that? Just so other people could assemble them, or because materials have gotten better and you can 3D print really strong stuff?
um, I mean, it's a lot of work to kind of design that in a way that you can assemble it in just three pieces, where
Hmm.
the plates give you a lot more flexibility, and I can change this design out if I want. Where if I do machined parts, I like to use my motors a few times and the magnets a few times, and changing
Hmm.
plates out kind of lets me play with some of those electromagnetic properties of the speaker. Where if I'm just stuck in this machined part, I just have to run that same motor. And I mean, so it's fine if I'm testing other parts of that speaker, such as the suspension or the weight of a cone, or like distances between things, shortening things up, lengthening things out, making a bigger speaker, a smaller speaker. So it's good for testing, like leaving that alone and then seeing, what does this change? What does this do? What can I fix here? What can I make better there?
Got you. Okay, I'm gonna also pick your brain for a video I'm working on, which is I'm trying to think creatively about. Let me give you the setup for this video. This spoiler alert for anyone who doesn't want spoilers of the video. Skip ahead 5 minutes. So you know me, right? And I think last time we were talking, I was trying to think of, okay, what are ways you can actually use X? Because I don't like when there's a technology and then, the manufacturers give us this technology, and then most of us just print flexi dragons, right? Like I want people to use. I don't like waste, right? So it's like tool changers and active, passive, index, all this stuff. It's all coming out now. And I don't want to see people just printing multicolor. It's like, dude, multi-material is so freaking cool. So the premise behind this video is, let's think of all the cool ways that we as a community can experiment with multi-material that's actually functional, right? We've all seen the spine model with the flexible vertebra. I'm talking like real functional. And I'm really curious, thought experiment, how will this change speaker design for you? Or will it be, like, would you multi-material print a driver with flexibles and rigids, or?
So I've actually played with that a bit. I have an old IDEX machine, an old Flash Forge IDEX machine. So, and it was a direct drive one, so I could load TPU in one side and I could load PLA or PETG here. And I actually printed where you would print the basket, and then you would have the TPU and the spider print as a flexible material, and then you would have the cone again as the hard material. And I played with it. I never did any videos on it or anything. It was kind of funky getting the supports out of there, because I really needed a third material for like support interface between everything that I could maybe just like soluble away or something. But I mean, overall, like locking the parts together and the concentricity of everything, it was leaps and bounds better than what I can do just eyeballing stuff. So I mean, you could, because that's kind of the efficiency of the speaker is really dependent on how concentric and symmetrical you can get everything assembled. And so if something rubs even just a little bit, or you have something just tilted just the ever so slightly, like you pulled the surround off the bed and you kind of stretched it a little bit when you pulled it off the bed, it now makes that cone sit just like a quarter of a degree sideways. But a quarter of a degree at 3 or 4 inches means it's now rubbing that little point, because I think I'm running a 1.2 millimeter air gap down there at that. So I have between a plate and a plate, there's a 1.2 millimeter gap that has to have a 0.4 millimeter vase mode like former, and then 2 layers of copper wire, like 32 gauge or 34 gauge copper wire wrapped around it. So there's just no room for any errors. And I mean, I'm running a tighter gap than most will on that type of stuff.
This might actually be, so I have 20. The list is currently 20, which is why you all should still watch this video, because I've thought of 20 in conversations with people, 20 weird and interesting and I think very exciting uses. This might be 21. So let me just vocalize what I think you said and you tell me if it's right. What you're saying is these parts could easily just be glued or assembled or, stretch one over the other, but I would damage them. Why not just let the 3D printer perfectly assemble the pieces for me in a way that I'm not going to damage them and I know everything is perfectly aligned? Yeah, that's totally 21. Thank you. Wow, that's freaking fantastic. I will credit you in the video, because 21 is definitely a better number for a thumbnail than 20. Odd numbers elicit a better reaction from people than even numbers. Okay. All right. I have some writing to do. Thank you. What are some other things? I mean, PLA and TPU don't bond together. Do you think you would actually like design rigid areas into speakers, or another interesting idea, like the foaming TPU as opposed to acrylic, to get exactly the amount you need?
Yeah, I mean, I could definitely see using a lot of multi-material, and I could also see doing like you want the basket to be very sturdy, so you would print it out of like a solid material, and then you would
Right.
use a foaming TPU for some of the movable parts. But then you could move to another foaming like PLA, PETG, ABS. I
Yeah,
don't know if any of those exist, but you
they
would cut down
do.
a ton of moving weight on all of that, and then it would still be perfectly concentrically assembled. And I've seen where they can tie them
Whoa.
in internally with like
Huh.
geometries internally to tie
Yeah,
the
yeah.
rubber parts to the hard parts so that you don't even have to worry about glue or separations or anything
Oh
like that.
man,
And it would just
that
kind
might
of
even be
reduce.
another one. That's interesting. I'm realizing I should have had way more conversations with way more people outside of my, because my lexicon is like workshopy stuff and organization. I'm just realizing, holy crap, I could have gotten, maybe there's a part two to this video if I actually go out and talk to you and talk to Nadir and talk to other people that I know that design things besides workshop gear. Um, I did think of, and I think this is an interesting one for you. You have all these like PETG magnetite or PETG tungsten that are like extremely heavy, but in a lot of cases, you want, say you want something to be perfectly balanced. I think a speaker is a really good example, right? Where it's like you want the weight to be only in one part, but you want the materials to bond. And like you said before, gluing them together is not going to make sense. And I had thought of like if I need a very, very exact amount of weight in a very, very exact place, like doing it with sand is not going to work. Changing infill percentage, plastic is so light, right? Like 1.25 grams per cubic centimeter. But if you design a very
Mhm.
specific piece of PETG tungsten to extrude into that area and beam interlock, it's like you could control the amount of weight in such a precise way. Also, things like sand or metal, like
Mhm.
adding weight rocks, right? And if you're trying to control weight distribution perfectly. So I think that's a similar point to
Mhm.
yours. Um, but it's
Yeah.
really exciting. Like, I'm very excited about all this multi-material stuff. You don't realize, and this is part of why I want to do the video, you don't realize like how much cool shit you can do with it until you start thinking like, oh, well, I do have
Mhm.
three other extruders that are just sitting there. Like, why should I glue this piece by hand and then the glue is going to deteriorate over time because of vibrations? And it's pretty exciting. I want to switch gears and ask on that note, like what printers do you find yourself using the most for your design process?
Um, so I still actually use that Ultimaker too from time to time. Just, I mean,
Okay,
it's reliable. I nothing wrong with it. It's slow, but my God, because it's probably the most accurate printer I have in my fleet.
that makes sense.
Like
I mean,
you
it's an
want
industrial
something,
printer.
yeah, you want something with tiny, tiny threads or something. You throw it on a low layer height, and it will just go to town, and it makes things happen. And then,
Huh.
I mean, I
One
did
could
get
say
into a
it
lot
is
of the
the
bamboos.
ultimate maker.
Yeah.
What else you got?
Yep. Um, I did get a few of the bamboos because I was just seeing everybody saying they were just plug and play, go to town, and I was like, I am kind of tired of every time I want to create something having to go and tinker with this or screw
Yep.
with that or whatever.
Yep.
And so if I want to just sit down and really focus in on making something, they did actually kind of work out to be a pretty good just plug and play type printer. I don't
Definitely.
I'm not a super fan of the like garden style
Yeah.
environment that they keep you in, and
Totally.
it's not very good for like my business side where I'm doing stuff that should not be sent over the air, so I have other printers for that.
Okay.
um
Yeah. That makes a lot of
yep.
sense.
So,
Yeah,
yeah.
my thing with the walled garden is like I'm cool with it until the point where it bumps into me. So like with my Apple devices, I guess maybe I'm just not that much of a power user, but like I can kind of do everything I want. I used to jailbreak my phones, but then a lot of that stuff got added in. But it's like with the bamboo printers, so right now I'm doing all kinds of weird shit with multi-material and like trying to get the printer to do things that it doesn't want to do, and when it runs on Clipper, like the Snapmaker U1, I can just be like, hey, no, you want to do this, you want to, run this weird G code, and you want to let me, I don't know, I can't think of an example off the top of my head. But it's that kind of stuff where it's like, if you are a power user and you want to be able to do, have full control over the machine. So I think it's promising, like, to see more of these big companies, especially big Chinese companies, like, are now using open source software and publishing the source, hopefully soon.
Yep.
So you're mostly a PETG guy, or what materials are you experimenting with these days, print wise?
I mean, PETG is kind of it's my go-to. For me, it's easy to print. I know you don't share the same thoughts, but I live in a desert,
which is I actually really love PETG CF. I think it's phenomenal. It's everything PETG is not.
Yep. I usually have a roll of that sitting in one of the multi-materials, just ready to go.
Yeah. It would be interesting to plot on a chart, like just ask people 2 questions and plot it, which is, what is the humidity level where you live, and how much do you like printing PETG? And I bet you there's a direct correlation, because I talk to other people here in Israel, and they're like, oh yeah, I hate PETG. It's like the worst material ever. And then I talked to a guy who was from Moscow and moved here, and he's like, I used to really love PETG, but here I hate it. I was like, yeah, man.
Yep. Yeah, I think relative humidity here is like 28 or something like that. So
yeah, 75 here. So I can see why you like PETG. That makes sense.
Yeah,
that makes a lot of sense. Any other stuff you're excited about in 3D printing that's coming down the pike? You mentioned silicone 3D printers, but what other stuff are you hoping is going to trickle down, or do you want to see manufacturers come out with that would improve your workflow?
I mean, on the car end, I really like the push towards the higher heat materials coming into the home.
Yeah.
So,
totally.
like 2-3 years ago, to build an intake manifold or something for a turbo car was just, you didn't even think about it. And now, I mean, all this like PPS carbon fiber, and I think there's even a few of them now that'll do like, I don't think it's PEEK, but it's like the PEKK or something like that, which is the one that's below for heat.
Yep.
Yeah, I think that's becoming more readily available into the consumer market, and I really like to see that for my other hobby.
You've got the 400 degree C upgrade that was just announced for the Prusa Core 1 and Core 1L, and off the record, but not off the record, 400C is like what they rate it at, but it's Obsidian 500 technology from E3D. It even says E3D on there, and E3D rates it to 500. And at the Formnext booth, I didn't check the temperature. I'd have to look at my footage, but they were printing PEC CF on a Core 1, and it was like flawless. I mean, we're talking perfect layer adhesion. So I'm not going to recommend, I don't want to get sued if your house burns down, but do with that what you will. In an event hall where people were touching the printers and messing with it, they were just printing PEC CF like it was no big deal. And that's I think that's like a $400 upgrade for the Core 1 or something. It's mind-boggling. Now, would I try to print PEEK on it? Probably not, given the chamber temperature situation, but it's pretty interesting. What kind of heat deflection do you need for a turbo manifold? Because that to me sounds like in the 300s.
Yeah, so on the intake side, so obviously exhaust side, you're stuck to metal and metal only. So intake side, I mean, a turbo pre-intercooler will probably be between 325 to 425 Fahrenheit.
Oh, Fahrenheit. I was like,
so,
dude,
Fahrenheit.
No plastic is going to do that. 425 Fahrenheit?
Yeah.
It's 218C. Dude, you don't even need to go to the crazy stuff. What plastic did I just play with recently? PPA CF is 240 degrees Celsius.
Yep, I just seen that PPS CF, and I thought it was getting really close to turbo manifold stuff. For regular car intakes,
is
it
more
definitely
rigid,
will.
But less heat deflection, maybe.
That sounds right. I think it was around 180 or something, if I remember right.
Yeah. Yeah, but I mean, you can print plastics that would stand up to
Hmm.
that on your maybe
Yep.
on your X1 carbon. But yeah, we're getting interesting stuff now too. Like I've been playing a lot with this high temp resin that's rated at 270, which like it
Hmm.
doesn't register to me. Like when I got into 3D
Yep.
printing, and certainly when you got into 3D printing, the max of my hot end was 240. Okay. And now I have a resin that I can print that hits 270, like or is rated at 270. Now, should you keep it at 270? That's probably not for 6 hours at a time.
Hmm.
I would need to check that, but it's like it's rated to operate at up to 270, probably for
Hmm.
minutes at a time. I don't know.
Yep.
And what I've
Yeah.
realized, and we've talked about this on the channel before, is it is not linear. Like the difference
Hmm.
between 350 and 250 or 450 and 350 is not a linear jump, right? Like when you get up to the especially 450, like the I mean everything changes. I don't know exactly why, but it's just like every material that you would want to use, from here's a perfect example. The PCB that is I shaved this one down, but like the PCB that is a centimeter and a half away from that hot end at 450 starts to fail because of the radiative heat. Like it's
Hmm.
so much harder to get to those temperatures. So hats off to Prusa for
Hmm.
making an upgrade that'll just go on your freaking desktop printer and print this shit.
Hmm.
That's cool. Do you run any Prusa machines?
I do not run any Prusa machines. I have a
Okay.
Kitty or Quiddy or I don't know how
GD,
to
yeah.
pronounce it.
I think
Yeah,
it's
that
GD.
one. I have one of those that's rated for 370. One of the Max
Yeah.
fours, Max
I think
threes.
you can do some serious damage with that thing.
Yeah.
Like PPS CF no problem, and that'll do what you need.
Hmm.
It's
Yeah.
a very exciting time. Every time
Hmm.
some of this new stuff comes out, I used to say, oh, okay, yeah, but my audience is consumers. Like, come on, we're not really,
Hmm.
you know. And I think I even said that in
Hmm.
one of the videos. I was like, realistically, this is beyond what any of us consumers want to do. And then you realize, like,
Hmm.
consumers also is guys like you who just want to print a simple intake manifold for your car. Like, I wouldn't consider that pro grade 3D printing. I used to work on my cars all the time as well. It's like, one guy's video equipment or tripod extensions is another guy's intake manifold for his car, and that's a different world. Or like, you
Hmm.
know, another guy's crazy mount for his mountain bike that's going to be out in the weather and the elements and the sun and taking massive amounts of vibration. So I've stopped saying that, right? Like, oh, we consumers don't need this. Short of like the peaks
Hmm.
and the pecs and stuff,
Yeah.
Um,
Yeah.
I
Have you
think
ever
that's what's so
played
exciting, right?
with PVDF? You ever played with any of that stuff?
I've not only never played with it, I've never heard of it. Tell me more.
So I needed a 3D printed fuel pump basket for one of
Hmm.
my engine projects that I was doing. I was
Okay.
upgrading fuel pumps. I wanted a dual fuel pump setup. So this was probably back in 2020. So before a lot of the new fancy stuff. So
Yeah.
I did research and research and research and research, and nothing was going to mix with gasoline, plus the temperature of return fuel, plus just the harsh
Yeah.
environments of a fuel tank. And then
Hmm.
I came across this stuff, PVDF, polyvinyl dial something fluorine or something like that. And
Yeah.
it comes in a copolymer and a like a single polymer. And if you're gonna go look it up, sit down for the price of it. That's all I'm gonna warn you about that. But this stuff, I mean, it was solvents, gasolines,
Yeah.
it was gamma ray resistant, it was like abrasion resistant, it was basic, it was just all kinds of everything resistant. And I was like, oh my God, why are they selling this? And it was just for consumer grade. And temperature deflection, it was up there with above ABS, I think, for the temperature
Wow.
deflection, but it's kind of soft like a 70D, 80D TPU.
honestly
It doesn't have a
sounds
ton
lot
of
like
rigidity to.
HDPE, by the way. Which is this stuff. Because I'm pretty sure HDPE is like one of those super solvent resistant materials as well. Like when you buy bleach and you know all kinds of
Mhm.
alcohol, acetone, it always comes in an HDPE bottle.
But I don't think
Um,
HDPE was good for the high temperature. Was my
maybe,
issue because I needed it to do. I think
maybe.
I wanted like 130.
Oh yeah, that's tough. Hold on, I have this little AI plugin on my computer that I can just search right here. HDPE heat deflection temperature. I don't think it's 130. Yeah, no. No way.
Yeah.
That even like the funky formulas are 90. So there you go.
What's it say for PVDF? Just out of curiosity.
Let's see. PVDF heat deflection. Interesting. I mean, that's the other thing is you say to yourself like, why does this filament exist? And then you realize like in a lot of PVDF can go up to at normal pressurization 150. So there you go.
Yeah,
So
I knew
you
it was up
realize like,
there.
okay, why does this tungsten filament exist? And then you're like, oh, you know, some huge company went to one of these manufacturers and was like, we need this. And then they're like, okay, well, we made the formula, we have the pellets. If someone orders it, we'll make a spool for them. And that's probably
Hmm.
also why it's so expensive, right? Is they're manufacturing a few spools at a time. But
Yeah.
I'm working on another video in the series. Maybe I'll look that one up. A video in my filament series, which is like special purpose filaments. Like if you've got a
Hmm.
weird, interesting use case, this is the filament you
Yep.
need.
Little caveat on that. Uh, it is very dangerous over 300 Celsius. Don't put it
Yeah,
over 300 Celsius. Very, very
and
dangerous.
it prints at
Releases
like
horrible,
290
horrible
or something.
toxins. I think I printed it on a regular like Ender 5, to be honest
Oh,
with you. I think that's what I printed it on. At like
PVDF.
260.
Let's see if I can get my hands on a spool of it. Huh. Very cool. Well, it's been a pleasure chatting with you. I know it's like 2 a.m. for you, so I'm going to draw us to a close. But make sure to let folks know where they can learn more, where they can follow you, where they can check out your projects. Hit it.
Yeah. So everything's going to be on YouTube at Pisces Printing. I have a lot of stuff up on Thingiverse, a few things up on Printables. I think there's one or two projects up on Maker Lab. I think that's
Okay.
Bamboo's Maker Lab.
Yep.
Um, yeah, I do a little bit of the Twitter X stuff. I post the projects up there, a little bit of updates for stuff here and there. But my main social channel is YouTube.
All right. We will link it all in the description if it's not already linked there. And thanks for coming on, man. It's been an absolute pleasure. And thanks to everyone who tuned
Yeah.
in live. And stay in touch and let me know how I can help you with your various fun projects. All right, brother. Take care.
Yep. Later.